Okay, all right, let's get started. Let's talk about a few past paper questions from the topics that we have already covered, and then we will talk about some other stuff as well. Okay, all right. Now, this is basically the ninth question from an exam, and it says write 216 as a product of its prime factors. So it is easy, but still for the sake of completeness, since we need to do the second part, so let's do the first part as well. Okay, so the number is 216. Now, how do we do it? Okay, so everyone has their own method. I don't mind any method as long as that's correct. It's 216. The smallest number um, is going to be 2. So 216 divided by 2 is going to give me 108. And then again, it's going to be 2, and that would give me 54. And again, it's going to be 2. And this time around, I would get 27. Now 2 would not work. So it would be 3. This number is going to be 9. Again, it would be 3. Sorry. Yes. And then 3, and then it would be 1 and 1. Okay, so this is how we do it. So I can write 216 as 2 cubed because I have 3 2's, so I can write it as 2 cubed, and it is being multiplied by 3 cubed. Now some of you wrote 1 as well, like I got this as well. So no need to write down this one. Technically, it's not wrong, but we don't consider 1 because you can multiply 1 with any number in math. So we don't write down 1 as a prime factor because technically 1 is not a prime number, right? When we discussed prime numbers, I told you that number has two factors only. It's 1 and the number itself. So technically, if you talk about 1, the only factor of 1 is 1, right? So it's not a prime number. So 1 is not a prime number. That is why we don't write down 1, and this is going to be the answer. So I will write it down as 2 cubed multiplied by 3 cubed. Now this part had nothing to do with the second one, but still, for just to revise the old contents and all of that, that is why I did this. The next part is more important. Okay, but before talking about this part, do not read this for now. Okay, let's talk about the relationship between factors and multiples. Okay, if I say that 3 is a factor of 6, if I say 3 is a factor of 6, it means that in the multiples of 3, I would get 6. 3 is a factor of 6, and if I talk about the multiples of 3, there I would get 6. So what is the relationship? 3 is a factor of 6 and 6 is a multiple of 3. So this is basically the relationship between a factor and a multiple. For instance, if I say 2 is a factor of 10, that makes sense. I can divide 10 by 2. That is why 2 is a factor of 10. But 10 is a multiple of 2. Okay. 6 is a multiple of 3. One second, Umayza, let me finish, then you would understand. Don't worry, just relax, okay? 2 is a factor of 10 and 10 is a multiple of 2. Just think about it for now. Factors and multiples have this link. If a number is a factor of something, we can say that the other number was multiple of that factor. For example, if 3 is a factor of 6, then 6 would be a multiple of 3, right? You guys know that. You can divide 6 by 3, that is why it is a factor. And if we talk about the table of 3, you can find 6 there. It makes sense. We know all of this in our mind, but we need to revise this. 2 is a factor of 10, means that I can divide 10 by 2. Similarly, 10 is a multiple of 2. I am just talking about the relationship between factors and multiples, okay? 4 is a factor of 16. 16 is a multiple of 4. Try to understand this relationship. 4 is a factor of 16, makes sense. 16 is a multiple of 4, and you can think about infinite many cases of this type and it would make sense. One last thing, 8 is a factor of 32, and 32 is a multiple of 8. You guys know that if I talk about the table of 8, you would certainly find 32 there. Okay, so are we clear with this relationship?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, Umayza,
Yes,
what?
ma'am.
Yes. Oh, I'll come to that. I'll come to that, Umayza. I'll come to that. For now, just the relationship. Okay, so we know this thing. So now let's talk about the question. Okay. Acha. Now the question was, two positive integers are each greater than 25. Okay. Their lowest, sorry, their lowest common multiple is 216. Their highest common factor is 18. Find the two integers. This is what you need to understand. So you have two numbers. Both the numbers are greater than 25. If you will find the LCM of those two numbers, you would get 216. If you will find the HCF of those two numbers, you would get 18. What are the two numbers? Okay, so such questions are done by hit and trial method, but you cannot think about all the numbers greater than 25. Yes, Umayza, that's right. You cannot think about all the numbers greater than 25. That would take a lot of time. We need to take out some specific numbers using this piece of information. Their highest common factor is 18. It means 18 is the factor for both the numbers. So that means both the numbers would be multiples of 18, right? 18 is highest common factor for both the numbers. So 18 is a factor. But you need to think about the multiples of 18 to understand the concept, because we are looking for two numbers whose lowest common multiple is 26 is 216 and the highest common factor is 18. So the number has to be greater than 25 and 18 is a factor. So look at this. 18 is a factor of, think about numbers which are greater than 25 and 18 is their factor. For that, you need to think about the table of 18. Things would make sense. Please stay calm and listen to me first and then tell me if you are able to understand this or not. Okay. It's 18 multiplied by 1. That's certainly under 25. So we don't need this. 18 multiplied by 2. That is going to be 36. So yes, this could be one of the two numbers. Then we have 18 multiplied by 3. So the number is going to be 54. This can also be the number. We are not too sure for now. 18 multiplied by 4. So 18 multiplied by 4 is going to be 72. This can also be the choice, and so on and so forth. First of all, understand why am I talking about these three numbers? Because the number has to be greater than 25 and 18 is a factor. If 18 is a factor of some number, that number is going to be a multiple of 18. This is what I've just taught. Okay. If 18 is a factor, that number has to be a multiple of 18. So it could be 36, 54, 72. The only thing which you need to spend time on is to see which combination would give you 216. So let's say we start off by using 36 and 54. Let's try and see if their LCM is 216 or not. It's 36 and it's 54. So the smallest number is 2. It's 18. And then 54 divided by 2 would give you 27. Then the number is 3. It would be 6 and 9. Again, the number is 3. It would be 2 and 3. And then let's say the number is 2. It's 1 and 3. And then the number is 3. So it's 1 and 1. So multiply all these numbers and see if you are getting 216 or not, because this is how we find the LCM. Okay. So 2 multiplied by 3 multiplied by 3 multiplied by 2 multiplied by 3. This is 2 multiplied by 9 multiplied by 6. So 18 multiplied by 6 is giving you 108. So certainly this can't be the choice because it is not giving you 216 as the LCM. We need to have two bigger numbers. Let's use 54 and 72. Okay. Let's use 54 and 72. Things would make sense. Forget about the previous parts. Just focus on finding the LCM. Okay. For now, we are seeing what is the LCM of 54 and 72. Those who were not able to understand anything, please focus at this thing. Let's just learn how to find the LCM of two numbers. Okay. So the lowest number that's divisible by both is 2. 54 divided by 2 would give you 27, and then 72 divided by 2 would give you 36. Then it's 3, it's 9, and it would be 12. It's again 3, it's 3 and 4, it's 3, it's 1 and 4, and it's 4. So it would be 1 and 1. And this time around, we need to multiply all these numbers, and this is going to give you 2 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 4. So 2 multiplied by 9 multiplied by 12. So please do that on your own. And this has given me 216. So two positive integers that are greater than 25. 54 and 72 are certainly greater than 25. Their lowest common multiple is 2016. Here is the LCM. It turned out to be 2016. And their highest common factor is 18. So 54 and 72 are basically coming in the table of 18. And hence the highest common factor would be 18 for this case as well. Okay. So that is why the answer would be, yes, 1 second only, 54 and 72. Yes, now you can ask.
Ma'am, why did you not go further, like 18, 5, 7?
1 second, 1 second. Please keep your 1 second. Say it again. So say it again.
Ma'am, I'm saying that आपने सिर्फ 18,400 तक किया, उसके बाद आपने आगे
Yes. Okay. Okay.
आप वहाँ पे क्यों?
Certainly. That is a good question. I'll tell you. I made these dots. Okay. And these dots basically meant that if these three would not work, in that case, I would have certainly looked up for 18 multiplied by 5, 18 multiplied by 6. But by now, through practice, I know if it is a 2-mark question, the examiner cannot be that cruel. He would not make things too much difficult for you. I had this idea in my mind that things would be clear between these three. But certainly, if 54 and 72 did not give me 2016, I would have calculated 18 multiplied by 5, and then I would have picked up 72 and the next number, certainly. But since things worked, that is why I just stopped at this point. Otherwise, yes, you are right, I should consider all the multiples. But since things worked in the beginning, so there was no point in talking about the other numbers. Okay. Yes, no, Miza, this took time because initially I had to explain the idea, but otherwise things should be quick, right? It was just this, that the number had to be greater than 25 and their highest common factor was 18. If a number has 18 as its factor, the two numbers would certainly be the multiples of 18. So first of all, I stated all the multiples of 18. And I did this way to explain you guys can, by the end of the session, you guys should be good enough to understand if it's 18, 36, 54. Just do it roughly and then write down the numbers and then try finding out the combination of LCMs and see if you get 2016 or not. Okay, this is the idea. So it would take time initially, but when you will practice more questions of this type, you would understand the idea. Yes, Umayza, is it better? And what about the other
Yes,
students?
Yes, ma'am.
yes, ma'am.
Okay. All right. Okay. I hope that this question is then genuinely clear. Okay. All right. Let's talk about the next question now. Okay. This was another question which I could see most of you were not able to do it correctly. Let's talk about it now. Okay. 40 students can take part in three activities: art, dancing, and gardening. 5 do not take part in any of the activities. Okay. Then 12 do arts only. 4 do dancing and gardening, but not arts. 1 student does all three activities. Complete the Venn diagram. So this part was correct for most of you, but let's just do it for the sake of completeness. 5 do not take part in any activity means it would be outside A, D, and G. So I can write down 5 anywhere outside these three sets. Then 12 do arts only. So for arts only, this is for arts, it would come over here. If I write this 12 here, it would be both for arts and dancing. If I write it here, it would be for all three. So that is why I was supposed to write it down there. 4 do dancing and gardening, but not art. So dancing and gardening, but not art. So it would come here. And 1 student does all three activities. So this is how we just fill in the Venn diagram. Okay. This was just the first part of the question. Let's talk about the second one. That is important, and this would help you understand the...
Yes, can you explain it again?
Yes, definitely. The filling of Venn diagram. Okay, I'll tell you. So Venn diagram has basically a universal set, and then we had three sets. Okay, arts, dancing, and gardening, A, D, and G. And we had some information given using which I filled in the Venn diagram. 5 students do not take part in any of the activities. So since 5 students are neither doing arts nor dancing nor gardening, so I wrote 5 outside the 3 circles. This circle is first for arts, this was for dancing, and this was for gardening. That is why I wrote 5 outside the 3 circles, but still it would be inside the universal set. Okay. Acha, this was the first thing. Then the second piece of information was 12 to arts only. So arts only, like they're only doing arts. They're not doing arts with dancing. They're not doing arts with gardening, only arts. So I wrote 12 over here. And this is basically the section where we have arts only. This is the section where we have dancing only. And this is the section where we have gardening only. Okay. So this is why I wrote 12 there. Then 4 do dancing and gardening but not art. So dancing and gardening, common intersection for D and G where A is not there. So it was basically this one. This is the common intersection for dancing and gardening, and here I wrote 4. And then one student does all 3 activities. So this is basically the point where all 3 sets are intersecting: arts, dancing and gardening. That is why I wrote 1 here. Okay.
Okay, understood.
Yes. Okay. All right. Perfect. Okay.
Ma'am,
Hmm?
ma'am, the 5 is not visible, ma'am. The 5.
Sorry. That's because of the colors. Okay.
Yes.
Okay. All right. Acha, for the second part, it says on the Venn diagram, the ratio of x, y, and z is 1, 2, 3. Find the value of each x, y, and z. So we will do this part once we are done with the chapter that we were discussing yesterday, just so we are done with all the concepts of rate, proportion, and ratio. Then we'll come back to it and then we'll solve it. Okay, so for now, just leave this question, because things would make more sense. I can explain it to you right now as well, but this would be very, very complicated for those who missed the yesterday's class, who were not able to understand anything because that was the first class. Okay. Acha. Yes, we can do the third and the fourth part certainly. Okay. Now, one subset in the Venn diagram has no students. Use set notation to describe this subset. Okay. Has no students. Let's scroll up and see which part exactly they're talking about. 0. So they are basically talking about this part of the Venn diagram where we basically have the intersection between A and G, but D is not included. Okay, that is what we need to understand. So you need to write it down using the set symbols and explain the or point the red shaded region, but you're not supposed to write it down in words. You're supposed to write it down using intersection, union of different sets and stuff like that. Okay, let's put this thing in words. Okay, so this red highlighted region, let me just shade that properly. It's this entire region. It's basically, it's the intersection of A and D, A and G, and D is not included. Okay, so if I was asked to write it down in words, I would have written it this way. So what can I do? I can write down some part of it. It's intersection of A and G. Certainly this set is A, this set is G, and the red part is basically the intersection of both these sets. Okay, it's A intersection G. But if I write it down this way, this would basically mean I'm talking about all of this part. However, that is not true. I am only talking about this part. The other part is not included. So for that, I need to find its intersection with the complement of this set. Why have I done this? Now listen to me carefully and then ask me questions. Okay, what is this? This is A intersection G. This would give you this entire thing. In order to get rid of this extra shaded part, I need to talk about the intersection of D complement. It said D is not included. So whenever we have not D or D is not included, for that we talk about complement of that set. Okay, so when I will take its intersection with D complement has everything other than D. Let me just shade D complement. D complement is going to have everything except D. Okay, so other than the circle of D, everything would be shaded. Please pay attention. Things would make sense. Other than the circle of D, I've shaded everything. And now I'm interested in finding out the intersection of this thing and this thing. So we need to talk about the common region, the region where red and green both is there. Okay, since red and green both are basically corresponding to this part, that is why this is the shaded region, and that is why we use this set notation to explain this shaded part. So for exam, just know some part of the, why did we shade this? Because the question said one subset in the Venn diagram has no students. Okay, so for that we scrolled up and we just had to observe where do we have zero number of students, and this red highlighted part or this red shaded part had zero number of students. Oh, Maiza, forget about the second part I've just told you. We'll talk about this part later on. For now, we're talking about the third part. Okay, this red shaded part has basically zero number of students, and in order to explain that in set notation, we just write it down in words that it's intersection of A and D. So that would have given you this entire thing, but we are not interested in this entire thing. We are only interested in the red part. For that, we had to write down the intersection with D complement, and this is how it is going to be every time. For example, let's say if the question was one subset in the Venn diagram has 4 students, use set notation to describe this. 4 students would have met, would have meant this part right here. How do I write down this as set notation? It's the intersection of D and G, D intersection G, but then if I talk about this would have been this entire thing. I'm not interested in this entire thing. I'm only interested in this part. So for that, I would have taken the intersection with A complement, and this is going to be this region, right? So every time this method would work, okay? Every time this method is going to work. Let's say, let's talk about multiple scenarios, as many scenarios as you guys want. Let's say the question was has one student. Okay, let's say the question was it has one student. So that would have meant this what? Let me use a different color. This one. So what is this? This is the intersection of A with D and G. It is A intersection D intersection G, right? It is the intersection of all the 3 sets. It is the point where 3 sets are overlapping, and that is why I wrote this set notation for this part. Yes, now ask me if you have any questions. Yes, so Maiza, is it clear now?
No.
Okay, all right. Kabir, Urva, Hassan, Abdullah, and Ariba, yes, anything?
Yes, ma'am. No, ma'am.
No, ma'am.
Ma'am, understood.
Okay, all right, okay, perfect. So this part would be done later once we talk about this chapter that we were studying. And then, okay, this part. Find the number of elements that we would have in this part of the Venn diagram. So step 1 is to see what part exactly are they talking about at this point. Okay, first of all, you need to see what part exactly they're talking about at this point, and that would be the only thing, because we would not be sure about the values of x, y, and z. So we'll write it down as x plus, whatever we would have. Anyways, D union G intersection A. First step is to see which part exactly it is on the set. Let me erase everything. I'll write those numbers again. It was 12, 1, 4, and 5. And it was D union G intersection A. So the question was about finding the number of elements in this set. We would be in the position to find out the number of elements in this set. But before that, we need to see what part exactly are they talking about when they say this set. Okay. So we have our own method of doing this thing. Okay. I've been talking about this thing already. You need to find out the shaded part by naming or numbering different parts of the set. Let's start off with naming because numbers are already used. So this part is A, this part is B, this part is C, this is D, E, F, G, and H. Okay, so I have just named every different part of this Venn diagram, and this is how it is. Step 1, what elements do I have in D? Yes, I have D, I have C, I have F, and I have G. Okay, I am talking about the numbers only. So it's C, D, F, G. All right, what elements do I have in G? I have E, F, G, H. So we have E, F, G, H. I agree this would take another minute, but your answer would be certain and you would not be wasting your time in thinking about it. Okay. And then lastly, A. A has B, C, E, F. B, C, E, F. I am only talking about the names of alphabets because I have just entered those in order to understand the context. Okay. So first of all, D union G. It's in brackets. Let's find out the elements I would have in this set. D union G. Okay. All right. So this is D. This is G. In union, we write down all the elements, and if some elements are coming in common, we write those once only. So we have C, we have D, we have F, we have G, we have E. I won't be writing down F again because I have already written F. I won't be writing down G again because I have already written G. And then we have H. These are the elements I would have in D union G. Let me write it down more neatly. It's going to be C, D, F, G, E, and H. Okay. And then the elements of A and their intersection specifically. Intersection means common elements. So it would be C, it would be F, and it would be E. So in D union G, whole intersection with A, I have C coming in common, I have E coming in common, and I have F coming in common. So C, E, and F. I have this part. It's C, it's E, and it's F, this part. And the question was about finding the number of elements in this part. So what do we have? We have 0 plus 1 plus x elements. We don't know the value of x because we did not do the second part. We'll do that later on. But for now, you know, we have 0 plus 1 plus x elements in the set. Yes. Now ask me if you have anything that you need to ask about it. Any questions? Anything that's
Ma'am,
coming
could
to you?
you explain the labeling of the Venn diagram
Certainly,
again?
yes, definitely. Okay.
Okay.
So for the labeling, yes. For the labeling, we have two choices. Either you can number the Venn diagram or you can just name the different parts of the Venn diagram. Since numbers were already used in order to avoid confusion, I just started off by naming. How? Okay, let me erase this. entire thing because rest of the concept would be clear. And let's just name the different parts. Okay, so part A is basically outside these three sets. A is basically all of this part that is outside these three circles. Okay, but I am only representing that using a small a. Then it's B. Now this B is basically representing only the number of students which are in A only, right? Then we have C. C is basically the intersection of A and D without G. Then it's D. D is basically all of this part. Then it is E. E is basically all of this part. Then we have F. Then we have G. And then we have 8. So all the different parts of the Venn diagram are labeled using different alphabets. Is it okay now?
जी मैम आप समझ आ गए, thank you.
Oh, okay, no problem. Welcome. Okay, and A. Acha. Then I had three different sets over here. I started writing down the elements. One of the students has asked A. So A may, what do I have? I have B, I have C, I have E, and I have F. So I've written B, C, E, F. Okay, I've written all these 4 elements. That is it. Yes, Umaiza, is your question answered? No? Yes, say it again. And meanwhile, if any other student has anything, just ask me.
Nothing, ma'am.
Miss, there's no confusion from my side, but can
Okay.
you explain B part?
B part. What I can do is I can explain that to you separately because this would confuse the other students since we did not technically discuss this completely, right? Only I just want to spend another day, and then by the end of the next class, I would certainly explain this as well. Okay.
Okay, sounds good.
Yes. Okay. Okay, all right. So Umaiza, this is your question. This is basically the union symbol, and this is basically the intersection symbol, and intersection basically means the common elements, right? If you were talking about the symbols. Okay. Yes, that was your question. All right. Okay. Let's see if we have, yes, I had another question as well, but we can talk about that later on as well. Okay, let's discuss that quickly in 2 minutes. It says a school buys packs of pens and packs of rulers. There are 60 pens in each pack of pens, and there are 42 rulers in each pack of rulers. The school wants to buy exactly the same number of pens and rulers. Work out the smallest number of each pack of the school should buy. Okay. Now, most of you did not do it correctly because you guys just did some part of this question and you did not solve the entire question. 60 pens and 42 rulers, and they want the same number of pens and rulers, and it has to be the smallest number. So this is basically representing the lowest common multiple. This lowest common multiple would basically give you the smallest possible number that you guys can get for pens and rulers. So we need to take the LCM of 60 and 42. It's 42, and then we have 60. It's 2, 21, and 30 again. No, it's 3 now, 7 and 10. And then we have, you can say it's 2, it's 7 and 5, then it's 5, it's 7 and 1, and then it's 7, 1 and 1. Okay, so it's 2 multiplied by 3 multiplied by 2 multiplied by 5 multiplied by 7, and this is going to give you 420. This 420 is just the smallest, it's just the smallest possible number of pens and pencils that would be same. The question was about pack. smallest possible number of each pack. So if you want 420 pencils and 420 pens, how many packs of pens would you be buying and how many packs of rulers would you be buying? Okay, so we will do 420 divided by 60, and this is going to give you 7 packs of pens, and 420 divided by 42, and that would give you 10 packs of pencils. Okay, let me explain this again and then you guys can go. The idea was not to find the smallest possible number of pens and pencils that would be same. Yes, smallest possible number would be calculated by finding out the LCM, lowest common multiple. But once you have the lowest common multiple, you need to use that to find out the number of packs. So if one pack has 60 pens, and if you want 420 pens, you will do 420 divided by 60, and that would give you 7. And if one pack has 42 rulers, and in total you want 42 rulers, so you will do 42 divided by, you will do 420 divided by 42, and that would give you 10 packs of pencils, right?
Understood. But Miss, can we do it like within different numbers, as in 42 and 60? We can find 6 as their, common, and then 10 and then 7, because that's how I did it.
Yes, but that, sorry, say it again. Please, I could not understand your question.
Miss, yeah, I got the same answers you did, but basically what I did, instead of you doing 2 and then 3 and then 2 and then 5 and so on, breaking it down, I used much larger numbers because I just thought that made the process easier. So like I did 6, 10, and 7.
Yes, certainly.
Does it
Yes,
actually-
yes. I get your point. I get your point. Yes, obviously, that is also possible, but it's just our ways of finding out the lowest common multiple. Okay. The idea was to find out the lowest common multiple, that you can also think about as the smallest number that was coming in both the tables, and it was common. So it's your choice. It's whatever way you want to multiply, but that should be 420, right? The LCM, you need to find the LCM technically. For such questions, we will be looking forward to find out the LCM, that is the lowest common multiple. You won't get any mark for this, right? So it's completely fine if you had some other method and you got 420. That's also fine.
Okay, yeah, I understand. Thank you.
Okay, all right, welcome. And any other thing? All the students? Abdullah, Riba, Umaiza, Urva, Hassan, Sahal.
In word problems, what, how do you understand if you want to use LCM or LCM?
Exactly, that's a good question. So basically, for LCM, either the word would be least, lowest, or smallest, right? This is what I told Kabir in the very first class, that the examiner is never going, yes, he can certainly say find the LCM or HCF, but most of the times he would be using some alternate wordings, which you guys need to understand. If it's least, lowest, smallest, it would be the LCM. And if it is greatest, biggest, it would be, or highest, it would be the highest common factor, right? But you need to think about it logically as well. Now, certainly we cannot find factors here, okay? Because we were looking for the smallest possible number of pens and rulers we can have by buying a certain number of packs. So the idea made us think it was LCM, but if you don't want to think, if you just want some keywords, so the keywords would be smallest, least, lowest. Lowest would be used very less, because most of the times the examiner is using alternate wordings, and he would be using smallest and largest and words like these.
Okay, ma'am.